Some of the goals of our system are to provide communication system between surface and underground personnel via wireless two-way meeting. We want to communicate up to 1,000 feet, but more will be ideal. We want it to be practical for use and deployment, easy to carry for miners and to deploy underground. It must be rugged and independent because in a mine the conditions can be pretty bad, so you need to have something that's reliable. And also it has to meet various state regulations in regards to power supplies and stuff like that. Some of the challenges are transmitting underground various mineral deposits and water deposits and various compositions attenuate signal differently. We have to adhere to safety specifications. The canoe radio documentation is still it's not very complete at the moment. It's still under development, so we have to deal with in some cases, poorly documented features, and also remaining within budget and time constraints.
Time is one of the biggest ones because we have a prototype of our device, but it doesn't do exactly what we want it to do. So it's a matter of developing the new radio and building our own software to make the radio do what we want it to do. And we don't exactly know how long it's going to take because we haven't done it yet. So it could take, we could get it done next week, or it could take a couple months to really develop and troubleshoot the software. So time is the biggest challenge, I think, that we're going to encounter.
Okay, so in conclusion, through-the-earth communication is necessary because without the infrastructure in the mines or whatever else, there's no other way to do it, so you have to go through the earth. An effective solution is possible. With technology today, we feel that we can find a way to do it, just nobody's done the work yet and found the way to do it. Software-defined radio is really great because instead of having like a box that does one thing, you can change it to where it'll do anything you want it to. And then the radios have to be tuned to the mine conditions because, like Eddie said, the different overburden, different water in the soil, different things like that can attenuate the signal differently and cause problems.
So just as the software radio has limitless possibilities, you have phones now that do FM radio, they do GPS, they do 3G, they do wireless N, your G, your A. That's all software radio on a chip. So you know you can have a software radio could be any kind of radio you have the proper hardware for. Our mining communication project isn't just limited to the deployment of mines. What we're really trying to make here, what we're really looking to not lose sight of, is it's just a terminal. So point A, point B, communication through some medium. If we can do that, you can open up, the great underground for spelunking and rescuing cavers that are trapped underground. If they had a radio, they could talk to people, send information to the surface. You could get a better location on where they are, less people would die, like in that movie Descent. Everyone's seen that. For cave research overall, and this kind of ties into extraterrestrial applications. We can send rovers to Mars and now look at like Mars caves. Go and explore caves underground on other planets. And just the same here, places where people can't go, where people can't fit. We can explore caves and communicate wirelessly with robots. Seismic research, if all you had to do was deploy a sensor really, really deep in the San Andreas Fault, you could gather a lot of data and learn a lot about the seismic activity that's going on in the region before a big earthquake struck. And if you didn't have to have any kind of cable there or any way to tether it, then you wouldn't have to worry about how far it went down. You wouldn't have to worry so much about the placement. You just have to worry about getting a signal back. And for geothermal energy, you wouldn't necessarily have to have a huge shaft going down if you had like a bunch of systems down under the surface of the earth. You could almost bury them and leave them with nothing but pipes coming up. That would reduce personnel that would be required to service the hardware, or I guess the stuff that's underground. So this isn't just about rescuing miners. This is about opening up the wild, wild west that is underground. We can talk to space, we can talk to faraway galaxies, but we can't even talk up to 1,000 feet in our own planet. We kind of need to see what else is down there. We'll go to the next one. That concludes our presentation. If anyone has any questions, we'd be more than happy to answer.
Any questions?
Yes.
You mentioned that the antennas were directional. Now, how are you, now, I know that most mines are really, you mentioned that the antennas are directional, and I know that most mines are actually kind of sprawling. So how would you manage to pick up a signal from, let's say, a track miner if a large section of a mine was closed off? How would you know where to look? Specifically, how would they know where to point it?
Are you saying if we're using a directional antenna, how are we going to locate where they are because the line is so
How are you
bad
going to,
on the surface?
what system do you intend to put in place in order to have so that they know where to point these things, so that they'll be able to communicate?
The point, the best way I can put it is they're going to, the most basic idea, the fastest line for them to communicate from underground would be straight to the surface. If you go to a mine and they go 5 miles out from the bottom of the portal, it's not going to be the best idea to try and communicate straight from there 5 miles back to the bottom of the portal. It's going to go fastest to the surface. So we plan to, if they can if they set up the device underground and communicate straight upward, the mines will have various receivers. Mines have locations on the surface. Obviously, they don't own all the land that they mine under, but they have various portals and command sites and rescue chamber sites over the property that they mine under. So the hope would be that they would be able to turn on the units on the surface at all their locations, and that within that grid, it's like a node system, even though it's still wireless, that they would be able to pick up the signal and triangulate it based on their different locations on the surface as to where it's coming from, what section it's coming from, along those lines. I don't know if that answers your question.
Can they have something similar to the cell phones have a signal strength bar where they can rotate the laptop or whatever?
And that gets more into if we had our fingers crossed and our hopes and dreams all were granted, we'd have a cognitive radio, and it would sense the signal strength based on, or detect the signal strength and fine-tune the frequencies that were being chosen based on that to get a better signal. But we're not worried about a cognitive radio yet because we don't even have anything that will go through the air. So once we get there, we'll build something that's a little more user-friendly and a little more effective.
Okay, thank you very much.